What's up, everybody? Welcome to the Comet ML Office Hours, powered by the artists of data science. Super excited to have all you guys here. Thanks for joining me on this lovely Sunday, May 2nd. Can you believe that it is May already? It's insane. In about 1 week, less than 1 week, my son is going to turn 1 years old. That it to me is complete madness. I can't believe it. He's already a year. I can't believe we survived a year of him. But yeah, I'm excited for celebrating his birthday next week. I got him a kind of a really cool gift. He knows one color, and that color is blue, and he knows one object, and that object is a car. So what did I get him? I got him a blue car for his birthday. So he's gonna enjoy that. But yeah, man, welcome everybody. Super excited to have you guys here. We got some good friends in the building. We got Tor, we got Christoph. Good to see you guys again. We got some new names that I don't recognize. I see Arusha, Aditya, Renata. How you guys doing? So let's go ahead and get this party started, man. If anybody has any questions at all, please go for it. Feel free to unmute yourself. I'm going to mute you guys as you come into the room just to minimize background noise and stuff like that. But please do feel free to unmute yourself if you have a question. If you don't have a question, then maybe I can think of something to get us started here. So
Hi,
I was going to ask,
sorry.
yeah, go for it, Renata. You go for it. It's your floor.
So I'm the first time actually here joining you guys, so really nice. My question is rather simple, I would say. So what is happening? I'm trying to enter, or I'm trying to develop some new skills towards data science, and one of the things, the obvious thing, is actually practicing the theory. Here I'm struggling a little bit. I want to say probably with my motivation, because whenever I'm trying to think about a project that I want to do, it normally goes above my skill set. So obviously I tend not to finish it, or even, kind of dropping in a very beginning stage, because it's just, I'm not capable to do such a huge thing that I'm thinking that it would be really amazing and exciting to do it. At the same time, I'm thinking that the little projects, or kind of copy pasting what other things we're doing, is not as exciting and is not as useful in a generic way. So I was really wondering if there is a possibility to actually gain those skills while helping maybe someone or somebody, who needs that sort of help with, I don't know, very basic steps, because I'm learning. I'm at the very beginning stage. So obviously, um, I don't know, from labeling data, maybe someone needs that type of things, maybe cleaning data. So I was just really wondering if there are these sort of organizations or these sort of kind of NGO platforms, something that, let's say, beginners as me would be able to uh, give our time, and at the same time learning the necessary skills.
Yeah, it's a great question. I think the first thing that pops to mind is organizations such as, or the equivalent of, based on where you're located, like Data for Good or Data Kind or Driven Data. Companies like this that provide pretty much data science services, but for nonprofit sectors, I think that might be a good bet. But let's just roll back just a little bit before we jump into there. Let's talk about this aspect that you brought up about how you're not completing projects. Because honestly, doing projects is like the probably the most important thing that you could do to develop skills. So when you say you are starting to work on a project, but you stop because of uh, you maybe you bit off more than you chewed, like give me an example of that.
Yeah. Okay. So, for example, my work experience is recruitment. That's where I'm now. And one of the projects that I wanted to do is actually see if I can create a model to predict how long person will be staying in a company. And this is something that when I was, trying to do a research, there are people who were doing this. I don't know how good those models are. Some of those I could understand from what was written. Some of them were much, above my head. So I was not spending too much of a time on that. Um, but yeah, so So that was exciting idea for me because I could apply my knowledge of the field, and again, build skills on that one. My struggle, I started struggling quite at the very beginning when I realized that I don't have actually a good data set. And the ones that I could get my hands on were not satisfying to me because it was either the fake ones or it was such a limited amount of data, and it was nothing that I could really base on the theories that I knew that could be really valuable and really predict if how long person would be staying or at what time person would be leaving the company.
Mhm.
So yeah, that's one of the projects.
Yeah. So I think at this point, just based on what you're saying, right? I would not optimize my efforts for usefulness of what I create. I would optimize my efforts for what I can learn in the process of doing the project, right? So I think the first step would be kind of just ignore this idea of having a useful model or anything like that, right? Like you don't need to worry about that yet. I'm not sure where it is on the skill spectrum that you currently lie, but I'm going to guess that it's probably somewhere left of the middle, right? You probably got some skills, but maybe not terrible amount. I don't, you can correct me. You can, if you want to give me some more color around that, definitely. So like
I
where
want
are
to
you
say
at?
beginner. Honestly, I
Okay.
think it's safe to say that I'm more beginner rather than middle.
So maybe just do the simplest possible project that you can do, right? Obviously, if you're good with like how to code in Python, maybe you just do a simple exploratory data analysis project, right? Or maybe you just start off with a notebook with a data set and you just practice writing object oriented code that you are reading in from like a helper file and doing some data exploration with, right? So maybe just practice some of those parts first, right? Then eventually just kind of gradually move up and up in terms of incremental difficulty, right? Maybe now you go from just working out of a notebook to, all right, cool, I'm gonna start writing Python scripts. I'm gonna try to make this as automated as possible. So I'm gonna start using some frameworks like cookie cutter data science or Kedro, where I can write code in such a way that I can just run it straight from the command line with, a couple of keystrokes. Um, and maybe just focus on having a project where you develop an end-to-end pipeline where maybe you upload a CSV somewhere, maybe not even upload a CSV, just have your program read a CSV from your hard disk, do some transformations to it, right? Clean it up, have that result then get passed through to a model, have the model make its predictions, and then have those predictions stored on a local database on your local machine, right? So maybe that's the type of project you should probably try to optimize for and develop this core skill set around that. Because from that core skill set, being able to do that, everything else is just a little bit more of an extension, just a little bit more complicated version of that. Does that make sense?
Yeah, sorry. Yeah, absolutely. I guess it's just me, going, yeah, just getting excited about these big things, and yeah,
Yeah.
that's true that you need to start, walking before you start running. So
Yeah, so that would be like the biggest thing, right? Just focus first on just making sure you can write good clean code, and then once you have done that, maybe you've practiced, how to clean data in pandas, you practice how to do some exploration and things like that. Now say, all right, cool, I'm going to build out a pipeline, and all I want this pipeline to do is get this CSV from this location on my disk, and then walk through that entire pipeline that we just described, have it clean it, have it do some summaries, some aggregations, go to a model, take those results from the model, push it back into a database. But now the challenge now is like, okay, great. Here's a simple framework, a simple pipeline that I could do. What do I actually work on, right? So you're mentioning you got toy data sets that you're just not excited about or thrilled about. But there's things that we can look at, right? To help make it more fun and more exciting. For example, there's the website OpenML. Are you familiar with that? I think you might be muted. Oh, you just leave yourself unmuted, Renata. That's fine. We're gonna have a
which one?
conversation here.
Sorry.
OpenML.
No, actually,
So yeah,
I
I'm gonna
want to say
pull it
it's
up
the first
on.
time.
Yeah, I'll pull it up on the screen here. So for everybody that's listening to the recording of this on the podcast, you can switch to the YouTube video. But here's OpenML. And OpenML just has a bunch of really cool data sets. The thing is that you might not necessarily know what the data set represents, because the features will be anonymized for a lot of them, but you got a bunch of different types of data sets here. So this is entirely an option for you. And then there's actually a package in Python, the OpenML package, where you can just get the data sets directly through that instead of having to download the CSV and do all that. There's an API where you can just in Python where you can get the data. And there's a bunch of different data sets here. So that's one place to start. Another thing is, let's just think about your geographic location. So where are you currently located?
Luxembourg, Europe.
All right. So let's see. I'm sorry, I don't know how to spell. I'm sure Google will correct my spelling.
Yeah, it will correct.
All right, cool. So there's a public data portal for Luxembourg. So that's cool. So maybe what you want to do is, okay, I don't understand anything on this page, so I'm going to translate this to English and hopefully I can understand it. But there's a bunch of different data sets here for Luxembourg's open data portal that you can look through, right? And there's a bunch of interesting things you could do if you just kind of dig through the data they have here and build out like a mini project. So a friend of mine did this project, Mark Nagelberg, a friend of mine from here in Winnipeg. He used the city of Winnipeg's open data portal, and he did this really interesting project where he just looked at all the trees that were planted in every single neighborhood in Winnipeg and did some type of exploratory data analysis for that. There's also, and I was thinking about doing this project, but I did not do it, but there's data from the city of Winnipeg's open data portal about parking tickets, and it's got a bunch of information about the parking ticket, the location, the type of offense, the time, so on and so forth, right? You can also get demographic data for each neighborhood through the city of Winnipeg's open data portal. So maybe an interesting project to work on is there a link between the demographics of a particular neighborhood and the incidence rate of parking tickets? So are the parking officials disproportionately targeting a certain type of neighborhood for parking tickets? So things like that could be fun and interesting for you to work on. Let me know if any of this is applicable to you or if it's making sense. I'll pause right now.
Yeah, absolutely. And this is something where, again, I think probably the first thing that you mentioned, that, starting with something simple, probably that's indeed where I need to kind of, really start something with, because when I started looking in interesting data sets for myself, I turned, because by education, I'm a psychologist. So, by nature, I'm actually very much behavioral, okay, and I get into all these huge data sets that are really, so I need to clean up so much, and sometimes I don't even know how to clean up correctly. So again, that's a struggle, and it ends up eating a lot of my time. So I think, yes, it's absolutely something that I can use for motivation for probably a second step, thinking about a original project for myself. Surely, something around my location that motivates. And yeah, as a second step afterwards, once I already building a little bit more of a skill set.
Yeah, or even like just reframe the project, right? Let's say you're talking about just right now data set cleaning, pain in the butt for you. How about just say, all right, this is a data cleaning project, and this is my little data cleaning project. And you can still write good code, clean code around that, and try to make it extensible as possible, modular as possible, so that what you're doing can maybe apply to almost any data set, right? And you don't necessarily need to put the data up on GitHub, but you can still share your good, nice, clean, well-written code about how you clean this data set, right? And make that a little project. Just try to reframe some of, I'm talking to you about psychology or psychologists, so I guess you you get what I'm trying to say here, right?
Yeah, absolutely. Yeah. Putting, in a kind of still making a goal out of a project that is rather, kind of simple. But that brings actually a little bit some additional question. because how should I know the best practices? Like I'm following Udemy, well, not following, I did a couple courses on that. I'm also planning actually to see and maybe proceed with BA in computer science or data science, still struggling to make a decision on that. But let's say when it comes to good practices, maybe there are some additional places, like if a beginner like me could actually share these codes with people and ask to take a look on it.
Yeah, you can share your code on like GitHub. That's one definitely like the most obvious place I can think of to share it. Um, that's probably what I would do. I'd share it there and then maybe make some friends either right here in this community that we have and say, hey, I've got some code. Would you mind doing a peer review for it? Join the Slack channel for the Artists of Data Science. Go there and post in the one of the sections and just ask if somebody can look over your code. That's definitely helpful as well. In terms of best practices, I mean, I don't know if there's best practices that exist in data science, to be completely honest. I know there's a few frameworks you should follow, right? Like CRISP DM, CRISP-DM. I think it's like the cross industry standard process for data mining. And that's kind of the data science process. So that's definitely worth checking out. And another resource you can look at in terms of best practices around how to write your code is, I mentioned Kedro is one. I think Kedro might be a little bit more opinionated and advanced for where you're at right now. So I'd look at cookie cutter data science. That is a good one. And there's a bunch of other interesting websites that I can link you to that are escaping me right now. Are you a PhD data scientist? I'm sorry, PhD psychologist?
Masters only.
Masters. Okay, so you still got some decent academic kind of experience. There's a particular website, but I cannot remember the name of it for the life of me right now. But it was geared towards how to write, good clean code, but for academics. I think I want to say it was called Software Carpentry. I think it was actually. Yeah, it's popping up in my feeds right now. So this might be worth looking at if you want to pick up more of those coding type of skills, and it's really user friendly and beginner friendly. So I've linked it right there in the chat. So software carpentry, it's just basically basic lab skills for research computing. And you'll get a good idea of how to write good code through that.
That's
Part,
great.
yeah. Let me know if I've completely missed your question, or was that
No,
good
no,
enough?
no, that's exactly it is, and I am also a little bit all over the place, but it's just because I think it's normal. It's a beginning. So it's, kind of you learning as you're going, and that's when you kind of realizing where you want to go to spend more time. So I'm
Yeah.
still in the search. So yeah.
Yeah, and it's just helpful for me, at least when I was doing it. I was like, all right, this is going to be a data cleaning project. All I am planning to do with this is clean data, and I'm just going to write good, clean code that maybe I can use for other data sets that are going to help me clean this data set, right? So that's
So
one.
ultimate,
Mhm.
sorry. So the ultimate goal is actually to write a code that will be applicable to any data set that you would be bringing in.
Not ultimately, like a lot of the stuff that you're doing is going to be only applicable to the data sets or types of data that you're working on hand. But there's some stuff that you can definitely write that's general for most stuff, right? Making sure that if a column comes in and you're intending this column to be a numeric column, but it's being loaded in as strings for whatever reason, that you're doing the right conversion, things like that. What I know, Christoph probably has some good insights here as well. If you want to know.
And I just wanted to add something to what you already said, Harpreet.
Yeah.
It's fine to make tiny projects, because you'll be surprised how much you learn, even if you think at the beginning that this project isn't difficult, because they always feel a lot simpler before we start. And when you jump right into the project, you realize there's a lot to learn, and even tiny projects will get you outside of your comfort zone, because you won't have anyone like on Udemy or something who will guide you. You have to solve problems by yourself, and you learn really a lot. And making projects difficult, and that's the main reason not to finish them. It's like you're a psychologist, so you know it. We need this positive thinking, and our brain has to like what to do in order to come back to it again. So if you want to learn like every day, if you make your project difficult, then you'll look for some reasons not to do the project because it's unpleasant, and that's the fastest way to abandon it. And you look for some excuses not to do the project today and tomorrow, and after 4 days or something, you don't feel like coming back anytime. That's what I wanted to add.
Yeah.
So it's fine to make tiny projects. You always learn a lot.
Yeah, absolutely agree. Like small discrete projects are definitely a great way to go. Jaya, let's hear from you. And then Renata, I'm going to link you to something right here in the chat. It's somebody did a Python data cleaning project. But just to emphasize my point, like not all the code that you write always is going to be applicable to every single data set out there. So don't interpret what I said as that way, because I think I might have said what I wanted to say in a not good way. Jaya, let's hear from you. And while Jaya is talking, if anybody else has any questions at all, please go ahead and let me know right there in the chat, and then I'll add you to the queue.
So Renata, so I hope I'm pronouncing your name correct. I come from a I come from a non-technical background, so I kind of feel your struggles as well. I don't have Python or R, anything of those skills. So I taught myself, and while I was learning, I was also giving up a lot because, there was no purpose to it. And I couldn't find a data set that kind of fit to what I'm looking for, to get me going. I would like drop a lot of stuff along the way and not feeling motivated. So what I did was, this is kind of crazy. I forced myself to get into like a MOOC program. The one I took was the Udacity. So I took their data analysis program to just force myself to learn it, the program, the Python, whatever that goes into it, data cleaning, data exploration, and all that stuff, because I needed to be accountable with something. And, this MOOC programs, you have a deadline, right? Like 6 months or 7 months or something like that. And I think it was like a year for this one. So if you don't finish on time, I paid for it too. So you don't want your money to go to waste, So that one, because there was a payment attached to the program, and it made me accountable. Oh God, I got to finish this within a year, because I can say, there are other external situations that might kind of say, oh, you're too busy, don't do this data analysis course. You got other things that you want to do. But because I did this program, it forced me to kind of sit down, and, every day I would sit down, every night actually, because I'm a mom and a busy mom, and I would sit down every night after the kids go to bed. I would sit and do it little by little by little by little. So then, as you accomplish these tiny wins, it becomes like, oh, okay, I know something today which I didn't know yesterday. Then it just kind of accumulates, and you feel you begin to know more. And I would say you will be Googling a lot of stuff outside of the Udacity program, because there are a lot of things they say. Because the thing about boot camps is they expect you to know some stuff already, even though they say it's a beginner, So you'll be doing a lot of research, Googling outside of the pro boot camp to kind of catch up. Let's just put it. And it's a good thing, because anything that you learn is never, ever wasted. And it's a struggle. I will say it will be a struggle. Nothing comes easy. And I struggled a lot, especially when I was a non-tech person. I had to learn how to program. I didn't know little simple Python, zero, nothing. So yeah, for me, what worked was I enrolled in a paid program, and I had to hold accountable for it to kind of finish it.
And then, now that I know how to analyze data, then you can go and get your passion project or anything that you love, and you start to do stuff with it. So yeah, that's my input. Yeah.
Thanks, Jaya.
No,
So
absolutely. I can relate to that. And that's one of the reasons why I'm considering, this, well, it's online BA degree, in this, as mentioned, computer science, well, or data science. They have two programs. So that's actually what I'm looking, having this
Yeah.
accountability. Yes, it will be costly. Yes, of course, I will be paying money as well, but there will be exams, so there will be deadlines.
Yep.
So
Exactly.
that's something that
and being and online learning is
behind.
online learning is a very lonely world, let me tell you. You don't have anyone guiding you. You don't have someone tapping on your shoulder or a teacher tapping on your shoulder to do stuff. And so it's a lonely world. But you just have to bite the bullet and just go for it. And there are forums in there and stuff like that. That model worked for me because I was working plus being a mom and all that stuff. I needed something where the time is mine. I can control the time as to when I want to study, where I want to study, that kind of thing. But it's a lonely world, so just be ready for it, because there will be ups and downs while you're doing it in the boot camp too. So, but you just have to think about the little wins that you have and just keep moving forward. It might be tough, but keep moving forward is all I can say.
yeah, thanks
Thank you.
for that.
That's very inspiring.
Yeah, and if I don't know if you've looked into Udacity's nano degree programs, but if you're the type of person that likes those really structured type of courses with the accountability and deadlines like you had mentioned, I think those nano degrees might be a good option for you. So definitely look into those, as opposed to doing just a full-on bachelor's degree, especially if you already have like a master's, right? Like getting a bachelor's in data science might be a little bit of overkill, but it's entirely up to you. Check it out, see what's going to fit you. So there's a link here to Adventure of Code from my friend Elke. I've met Elke at Data Science Go Virtual. Good to see you here. So definitely check that out. That might be helpful for you as well. It's just composed of small exercises that will get harder and harder over time. They have you transform data and work with different types of data, and conscious of how performant a particular approach is. That's really pretty cool. So definitely check that out. I'll be adding that resource to my list as well. All right, Renata, thank you so much for your question. All right, so
Thank you, everyone.
Yeah, so Suman, if you got a question, let me first put you in the queue because somebody did send me a question through the message here.
It's not a question. It's
Okay.
about just continuing to the discussion.
Yeah.
So this is for Renata. I'm currently doing a boot camp at Flatiron, and from my experience, I think boot camp can be expensive, and the depth of material that teach you, I found it's almost same as some of the online courses at like Coursera or EDX or whatever. So I like from my personal experience, I think pursuing a online course would be better at like EDX. There's a nice course by MIT, like MicroMaster Data Science, which is way cheaper. I feel like I kind of wasted my money at doing this bootcamp because I was hoping to go into really great detail and learning more, but that didn't happen actually. So it was kind of disappointing. So my piece of advice is maybe if you're just jumping in first, like get into those MicroMaster program, which is way cheaper from there, and then you can like dig into further.
Right on. Thank you very much, Suman. Appreciate that. So let's head to Aditya. Aditya, go for it. You can unmute yourself.
Harpreet, you can hear me?
Yes, I can hear you now.
Is my voice clear? Because there's power fluctuations at my place.
No, sounds loud and clear. Loud and clear for right now.
Yeah. Okay. First of all, thank you so much for inviting me here. And I really have a quick question. So currently I'm doing a data science internship at IIT. And IIT is a top institute here in India. It's an engineering institute. So my professor, like, he asked me to work on transformers. Okay. So I hope you heard of it, the transformers. As a research intern, I have to basically do some modifications such that to see how this model behaves. Okay. So I'm quite confused. Like, I have read several papers, several similar papers to transformers. Okay. I'm like, I'm still confused. Like, what kind of modifications I have to do to improve this model, or how to make this happen. So can you just tell me how should I just get started with research and do stuff? That's it.
Can I just teach you how to get started with research and do stuff? All right. Yeah, let me show you what I would do. So first of all, I don't know much about transformers like at all whatsoever. That's not something that I'm very well versed in. I can refer you to a book by Dennis Rothman, who wrote Transformers, but I think his transformers are specifically for NLP. So I'm not going to have much insight to your particular question, but I will show you kind of what I would do to help me with any type of research that I'm doing, right? So for example,
Yeah, research
yeah.
mostly, yes.
So I'm a huge fan of Google's kind of like keyword searches, right? So that's a huge thing. Let me just show you what I would do. So I'm pulling up Google. So for those of you listening on the podcast, you might want to tune in and go to the YouTube to check it out. But let's say we're doing computer vision transformers, right? And we're looking for research papers, right?
Yeah,
So we know that.
exactly that.
So we want our file type to be PDF, right? And we probably don't want junk. So let's just make sure we limit ourselves to edu sites. And this is my entry point for starting. It looks like I spelled transformers wrong. So what I'm doing here is I'm doing a Google keyword search using essentially quotes to make sure that I'm finding that exact phrase. And then I'm saying, okay, file type :PDF, just give me only white papers. That's all I'm interested in. Site :edu, like don't give me none of the bullshit sites. Just give me educational webs, like, university sites. And once I do that, then let's say I look at this first paper here, Transformers Envision a Survey. Great. So what I'll do is I'll look through here, and once this loads, I'll show you. So I'll look through here and, maybe I have a certain particular word that it is that I'm looking for, right? If there's like a super particular phrase that I'm hoping to get from this, that I hope is unique, right? I'll say F, and let's just do F as like, I don't know, loss function, right? Do they mention loss function? Oh, great. Yes, they do. They mention loss function 8 times. Cool. So let me see what they mention about loss functions. Is this answering my question? Yes or no? Okay, well, it doesn't. So let's see what they're referencing. Okay, well, they got a bunch of references here. And then I scroll all the way down to the bottom, way down to the bottom on, in this case, page 28. And I started looking at the references. This is the great part about research papers, is that every research paper is going to have a shit ton of reference. So you just kind of go through these references and look through them, and maybe based on title, based on where this reference was mentioned in the paper, see if it's applicable to you, right? So this is like my very general high level approach to research, and then it gets more detailed, more nuanced as you go further and further into it. But here's the thing, man, like, you can't ask a question if you don't know what it is that you're looking for. So I'd say first get clear on exactly what it is that you're looking for. Then you can ask the right questions to get you the information that you need. At a high level, that's how I would research and do stuff, as you asked. Was that helpful at all?
Yeah, I mean, yeah, I totally agree. So, just like you said, I have been, like, over the weeks, I have read several papers. I have done like I've did seen the implementations and stuff, but I'm still kind of confused about like what my professor said. How do you paper you take an image classification paper?
Ooh, cutting off there, Aditya. I'm not sure what happened. Are you still here? So it looks like his audio cut out. You can try again, Aditya. All right. So if you want to type out which well, I can hear you now, Aditya. Do you want to say what
Hello?
you're yeah. Okay.
Yeah, I'm really sorry about this.
Yeah.
There's like very bad fluctuating here.
Yeah, no worries.
Okay. So yeah, I've read several papers and I have even implemented them all. But I'm like really confused like on what kind of modifications I have to do on a paper such that to improve its accuracy or to see or even how it behaves. Because first of all, the code is itself very intimidating. Okay. And on top of that, we have to do modification on that is a challenge. So how do you manage with these challenges?
Yeah, I'm not sure if I really understand the question, but I would just start by asking whoever's requesting you to do this to just be really clear on, okay, what is that you actually want me to do here, right? Do you want me to just read through papers, implement the code, and then do what with it? Do you want me to maybe find a area where I can improve this code, or maybe find an area where I can add more knowledge to what this person did to build on it, right? So just get really clear on what it is that you actually need to do, right? So two things that you need absolute clarity on to do anything, I think, productive in this world. First, figure out what it is that you're looking for, absolutely clearly what it is that you're looking for, and then ask very, very specific targeted questions to get you the information you need so you can answer any questions, right? So in this case, if you're saying, all right, I'm looking at code and the code is just super intimidating, well, maybe you can break apart the code, refactor it, making it a little bit cleaner. I'm not sure what it is that your professor actually wants. Based on the message that you sent me, it says that your professor told you to work on transformers and do some modifications such that to see the model behaves. Okay, so make modifications on what? I'm not sure. Modifications are basically techniques inspired from other papers, and I should apply these techniques to a particular task and check how it behaves. Yeah, so just experimentation, right? So maybe some modifications. Like I don't know exactly, like I don't know much about what code you're looking at, but maybe if this piece of code is looking at a particular value for a hyperparameter, then do some experiments around that hyperparameter and say, okay, if I fluctuate these hyperparameters, what happens? What changes? And run some experiments and compare and contrast the results. That's what I would say. So hopefully that's helpful. I see some comments here from Elke. So if you want to jump in, or was that just a comment?
Yeah, I can jump in, although
Yeah.
it was mostly still on the previous topic of learning and progressing in the data science, especially if you're a beginner. Like that, I feel like sometimes it does help if you work on a project with a group of people, especially if you know different aspects of data science, because you can learn from each other and build on each other's knowledge in the process.
Yeah, absolutely. But based on this question that we're having right here, okay, I know you're pretty well versed in machine learning as well. That's kind of your thing. Like, how would you go about doing this if somebody asked you to go and look at a research paper, look at the code, how it's implemented, and then make some modifications to that code and see how things change? Like, what would your process be? Or if you don't have a process for that, no worries. Don't worry about it.
Well, it's off the top of my head. I think I would start by really trying to replicate the research that has been done. So to see if I can get the same results as the researchers had, so that I make sure that I understand every part of the process. And then if you already have some ideas of what to change or where to experiment, then you can go ahead and log the differences and keep track of it. And then if the difference means that your model is improving, you can build on it. If it is not, then you've learned not to make that modification. And if you do not know what changes to make, I would say go further into research of maybe adjacent domains, things that are linked to it, but not exactly the same, and see if you can find any inspiration there.
Absolutely love that last bit of advice there. That is super important. So hopefully, Aditya, that helped. We're going to go ahead and move on now. So next question, I got Jaya in the queue for the next one. Yes, Jaya, and then after Jaya, I think the next person I have in the queue will be Arusha.
Okay, so this might be a stupid question because I don't know anything about this topic. So so I've got an interview coming up next week. In fact, it's tomorrow with IBM. So they've asked me, the recruiter told me to learn up or study, get familiar with containers, Kubernetes, cloud. So what is the linkage to data science, I guess, because I don't know anything about this stuff. So I just want to know, how is that linked to data science, and what do I need to know about it?
So in order for us to kind of when we're developing models, usually when we're experimenting, we're doing so in a computing environment that is maybe just our own computing environment on the local machine, right? But the environment that is on our local machine might not necessarily be the same environment that's on maybe Christoph's computer or Elke's computer, right? So in order to make sure that we have kind of a consistent environment, we put things into containers, right? And a container is just an image. And what this image is, you want to think of it as an image, like a snapshot in time of my current computing environment, meaning I've got all of these packages installed, I've got this type of architecture, so on and so forth, right? At a very high level, I'm probably describing it horribly, but a container makes it so that you avoid the question of, it worked on my machine, why doesn't it work on yours, right? So that's kind of in general what that does. And when you talk about Kubernetes is essentially an orchestration tool, right? So what this does is it just kind of like a puppeteer orchestrating resources, right? Like, and these are computing resources. And that's, I'm going to flip this one over to the software engineers in the house. So Christoph or Elke, if you guys want to come in here and chat about that.
I just agree with you. I mean, it's like those containers. You can think of it as like closed operation system, like where you've got all your packages or your programs installed, and when you move to another machine, you just do some stuff. I've never used it. I just know about it, and I know that people use it to deploy models, but I don't know how much time you've got to prepare about it, but I think it's pretty difficult. I don't really understand this, but I've never learned it. So, but it's like really technical, and it's not going to be easy.
Yeah. Elke, what about you? Have you got any insight that you can share? Because I know I probably did a horrible job explaining all of that.
Well, I think you did well, but I'm not an expert either. I think maybe what I can add is that I've noticed in some projects at the company that I work in that we build a sort of modeling engine, which is kind of a service or a product that we offer to other companies, which means that it has to be reusable. And for a lot of companies, especially larger companies, they want to have this solution installed on premises, and they want to have it working on the environment that they already work with. And if we containerize the solution, that means that, for example, even though we run it on Azure, it can be completely decoupled from any of these Azure specific things. And if they work, for example, on AWS, we can easily switch it and just have the container built there, and they can use their environment that they are comfortable with. And this also helps, especially in large companies, to make sure that the product can be reused. And I think in IBM's world, that might also be one of the reasons for containerization.
Okay. All right. Thank you very much. So basically what I'm understanding, Does this container, all that, if you build app, you put it in this container, and this container is actually flexible and portable in any environment that you put into, correct? I just want to know the high level. That's it. And because if they're going to dig more into it, I don't know. I'm going to just say I don't know. But I just want to just get a basic level. So this container can move around different premises. It's portable, and everything's packaged in. It could be, so these apps can be written in different languages and so forth, but they are within that environment. Am I right? In that container, right? Kind of.
Yeah. Just having it in a container just makes it just runs on my machine, runs on your machine, runs in the cloud, runs on any place that you put it.
Okay.
So once you're inside of that Docker container, then you're just replicating the environment where that thing was created, so that all the dependencies are there and everything it needs.
So when you say creating an image, so you have this container, you're creating an image. This is the image that moves around in different environment, different PCs, computers, and okay, so that's one. So Kubernetes is an orchestra of this whole container thing, that it kind of tells the systems, the IPs, hey, where you want to go, this is where you go, when something breaks, and it kind of, it's like the glue. Am I right? I'm just thinking
it's just like it's an orchestrator, right? Because you can have a bunch of different containers, and maybe you need to scale up, right? Maybe you need to you need more computing power. So Kubernetes will help scale up and scale down, and manage resources in that sense. There was a office hour for the Artists of Data Science happy hour maybe 3 weeks ago that we talked really heavily about Docker containers. So if you go to just go to my website, the Artists of Data Science .fireside.fm, and then type in like Docker in search, or type in container in search, and it should pull up the text file of the episode where we were talking about that.
But this is your podcast, correct?
Yeah.
Okay, gotcha. I will definitely look into it. Okay.
Yeah, it was probably the April 1st episode. I'd reckon start there April 1st.
Okay, perfect.
We had like an entire discussion about containers and stuff like that.
Kubernetes. So is there a difference? What is Docker then? Is Docker and Kubernetes the same thing, or is Docker containers?
The Docker is a framework for creating containers, and Kubernetes is a orchestrator, right?
Okay,
so
gotcha.
Different types of applications, yeah.
Okay, so the reason, so what is cloud? Is it just I guess I'm not sure what is cloud. So there's physical machines, and then there's cloud machines. Am I right?
So the cloud is essentially just data center, like servers in a data center, right? So when we say cloud, that's essentially what that means. It means our stuff is replicated all over amongst many different little laptops, right? You would think of it that way. Okay. Right? You have your local machine here, all of your stuff is here, but if your stuff is in the cloud, it's just like mini bits of your laptop in a bunch of different data centers. It's just essentially the cloud just makes things serverless, right? It just makes things completely serverless. If anybody wants to add a even better description than my horribly botched one, go for it. It looks like Sorb wants to, so go for it.
Yeah, cloud is essentially just imagine you have a company, you're running a company, and instead of maintaining your own servers, your own databases, all your infrastructure in your premise, all that headache, you are managing it. Instead of you doing it, you're giving it to a cloud provider, say Google, you give us compute power, database, everything you manage. We will just upload programs there. So it's all your headache to maintain the data centers and all the physical infrastructure. So that's the key advantage of cloud. And then you will pay some money to Google for managing all that stuff.
Yeah. Okay. So it just makes it so you don't have to manage and maintain your own servers and stuff like that. So it does a lot of the, what's the word I'm looking for? The resource management and infrastructure and platforms, all that stuff is managed for you by this, in this case, Google or AWS or Azure. Those are like the big three. So.
Okay. Okay, so yeah, just trying to link containers, Kubernetes, and cloud, all three together, and how data science falls into that. So when you're building models,
I mean,
data science,
you're
yeah,
talking more about like machine learning at this point. Like this is all software engineering concepts you're talking about. None of that is,
wow,
to me, at
data
least,
science.
it's a part of the data science lifecycle. But everything you're talking about right now, this is all the work of either a machine learning operations engineer, a machine learning engineer, a data engineer. Like these types of activities, I would not anticipate a data scientist to work on. Do they need knowledge on it? Yeah. But these are software engineering, machine learning engineering,
Okay,
DevOps,
maybe
data
they're going to
engineering.
ask me something very high level, nothing deep. I feel because this is a
What
data
what is the
science.
well, yeah, what's the job title that you're going for, right? If the job
It
title,
it's data science. So, but the recruiter told me just hey, just learn a little bit about containers and Kubernetes and IBM Cloud. So I
yeah,
say okay.
just know what those things are and where they are useful and how they can help facilitate the, I guess, the deployment of the work that you're doing.
Okay.
Yeah.
All right. Thank you.
Awesome. Next up, we got Arusha. And then after Arusha, looks like somebody wants me to look at the resume, which I can look at very briefly. If anybody else has questions, go ahead and let me know in the chat. Then I'll add you to the queue. But go for it, Arusha.
Yeah, hi, Harpreet. Am I audible?
Yeah.
Yeah. Firstly, thank you so much for having me here. So actually, there's just a lot of material online, so it gets really like difficult sometimes, and I'm trying to find like the best way to chalk out like a proper path. So on my data science journey. So I mean, to give you a little background, like I tried Andrew Ng's machine learning course, and I found that very overwhelming, and I don't know where to begin with stats. And recently, I started a career track on data camp. So I am familiar, like I have a computer science engineering background, so I'm familiar with algorithms, database, SQL, etc. And I've used like transfer learning in an image recognition project, but I feel like I don't have my basics, so I kind of just dove into the deep end. So if you have any recommendations on how to break into data science, and I know we've discussed this before about, picking up smaller projects in EDA and data cleansing and transformation, but should I be doing this next or am I missing something in the middle? So
That's a tough
yeah,
question for me to answer there because there's a lot in there. So if you're already good with computer science, you already know how to code. That's like half the battle. So that's good. So if
okay.
you're already good with software engineering, you already know your algorithms and your data structures and all your computer science stuff. That's cool. You're halfway there. Next thing I would do is just focus on how to create actual machine learning models, statistical models, right? So get good with statistics and probability and things like that. I'd recommend this actually. There's a book that I shared on my LinkedIn profile earlier today called Machine Learning for Absolute Beginners. That's something that I can recommend you check out. But in terms of, I mean, is finding resources the problem? I don't know, because there's so much resources out there. So I'm trying to really understand what it is that your question is, because
It's just,
yeah,
yeah, I'm sorry. It just mean not finding resources, just that there's a lot of resources. So as I was saying, I went to Andrew NG, I went to Data Camp. So I don't know what would be the best way to actually start my journey on data science.
So is the question, like, here's the thing, like all the resources, they're all the fucking same, man. Like data science, like there's not like one magic resource that will teach you the one thing that you need to learn that will all of a sudden make everything click. Like
Yeah.
that doesn't exist. So it sounds to me that it's not an issue of finding resources. It's a issue of creating a roadmap for yourself. Like, okay, great. There's a shit ton of resources out there. What do I need to actually know? Where do I actually start? Right? Is that kind of
Yes,
where it's at? All right. So I'm gonna just give myself a plug here for Data Science Dream Job. I'll pull this up. I'll share this with you guys as well. I can do that. Give me 1 second while I pull this up. So Data Science Dream Job, I don't know if you guys are familiar with this, but it is the coaching mentorship platform, which I am principal at. And this is just a way to help people transition into data science, provide them guidance and mentorship all along the way. And for that, we've got a bunch of these roadmaps, right? We got roadmaps for full stack data scientist, machine learning engineer, data engineer, so on and so forth, right? So I'm just going to zoom in on this one. Full stack data scientist, like this is everything that you need to know. eventually, not all at once before you get your first job, but eventually this is all the stuff you need to know. You see that we start up here with math, stats, probability, linear algebra, calculus, CS 101, programming, SQL, right? So if you look at this thing, it looks like an inverted tree, right? Almost like an inverted tree if you think hard enough. What's most important is this T-shaped stuff right here, right? So you focus on this stuff right here. These are the core skills that you need to be successful from day one on your in your job as a data scientist. And we start up here with math, stats and probability, then linear algebra, calculus, then some computer science, programming, SQL, then machine learning algorithms, feature engineering, model evaluation, model tuning, right? This is the stuff you should focus on. But stats and probability is massive, right? Like I've got master's degrees in stats and probability, and I've taken several actuarial exams. I still don't know anything about stats and probability because it's so massive. But there's a few things that you should definitely focus on, right? Obviously, knowing probability is a must, right? So knowing basics probability is essential, right? So be familiar with Bayes' theorem, be familiar with, the laws of probability, be familiar with some of the common probability distributions, right? There's normal distribution, t-distribution, chi-square distribution, Weibull distribution, Poisson distribution. I'm blanking. There's gamma distribution. There's all these different distributions that are common, and you should probably know about them. And then, from statistics, there's a number of things that you should focus on, most of which is probably in the realm of inference and hypothesis testing. So just be familiar with how to design an experiment, how to do what random sampling is, things like that. I mean, I'm going really, really granular at this point, but hopefully this is helping. Let me know. I'm just going to stop talking and drink water for a second and give you an opportunity.
No, this is great. I'm actually noting down everything. So.
Yeah, because I mean, these are huge fields. It's not like you need everything from linear algebra and calculus. Like, what do you need to really know from linear algebra? Well, you need to know what a matrix is. You need to know what a vector is. You need to know what the transpose of a matrix is. You need to know what the inverse of a matrix is. You should probably know how to invert a matrix. You should probably know what an eigenvalue is. You should probably know how to do a singular value decomposition. You should probably know what an eigenvector is. You should probably know, what else am I missing from linear algebra that you should probably know? How to multiply matrices just in general. Yeah, that, implications of columns in your matrix if they are linearly dependent. What does that do? Why is that bad? So those are probably the most important concepts from linear algebra that you should know. Am I missing anything? Anybody can join in at any second here. From calculus, I mean, definitely know what a derivative is, what an integral is, what a gradient is. Should probably know how to find the area underneath a curve, which is just integration. Yeah, so I mean, there's definitely just bits that are more important than all the others, I guess is what I'm trying to convey.
Okay, this is really useful. Thanks.
Yeah, so the book that I was talking about was Machine Learning for Absolute Beginners. Go to my LinkedIn profile. You'll see, I think I might have posted it earlier today or maybe even yesterday, day before, whatever. It's a orange cover of the book, Machine Learning for Absolute Beginners.
I think it was yesterday. Yeah.
Okay. Yeah, definitely go there. Check that out. Yeah, because I mean, I schedule out all my LinkedIn posts. I don't know when they post or what even gets posted. I just once a week I just sit down, schedule all the posts, and they just happen. But that's probably a good starting point. I would focus just on, instead of looking at a whole plethora of resources, just focus on one resource at a time, and then focus on that one until you're done, and say, okay, great. Now I need a little bit of extra here and there, and pick that up. So my one resource, I would say there's the O'Reilly book, Introduction to Machine Learning with Python. That should be good. I don't know, like I feel like I'm giving such blanket advice. If you want to chime in at any point, please do. Like, what is your actual, like I don't. I'm giving you a whole bunch of like prescriptions, but I don't think I know what your actual problem is. So if it's the road mapping part, we talked about that, but like what else is going on?
Yeah, so I think actually this is about it. Just kind of want to make a roadmap on how to get there. And
Mhm.
to give you a little perspective, I'm actually heading to Canada for my master's in management analytics this fall. So I just wanted to better prepare myself for this course. So that's all
Nice.
about.
Where in
And
Canada are you headed?
I'm going to Rotman, University of Toronto.
Oh, nice. Okay.
So actually, on in line with that, do you have any advice on maybe how to network or get in touch with people with like professionals in the Toronto area? I mean, as a professional yourself based in Canada.
LinkedIn's probably the best place to start.
Okay.
LinkedIn, or just come to things like this and talk to people. But yeah, there's a bunch of meetup groups as well. So if you go to like meetup.com and you type in like, data science or machine learning, and you can find meetup groups. Nowadays, all those meetup groups are virtual. There's also DAMA, DAMA, or DAMA. They have a chapter, I think, in Toronto. But those would be like the first go-tos I would say is join those meetup types of groups, and then connect with people on LinkedIn. Make sure that people that you're connecting with on LinkedIn are active people though.
Okay. Yeah. Thank you so much. And thank you to everyone in the chat. So they're giving a lot of recommendations, which was super useful.
Yeah, and I also recommend getting a jacket because it gets cold.
Yeah. Thank you.
Cool. So next question is, Jacob got a resume. All right. So Jacob, are you still here, Jacob? I don't know. So the resume looks pretty clean. I'll pull it up in a second here. But yeah, so talk to us about what's going on. So yeah, we talked on Friday, I think, at the
Yeah, we
happy
did.
hour.
Yeah.
Yeah, a bunch of advice on the struggles with what's going on. But go ahead, talk to us a little bit about
Okay. So before that meeting on Friday, I had an interview with a startup in Singapore. Sorry, I'm based in Lagos, Nigeria. So yeah. So it's just be like that, like having interview, not going to be beyond that stage, maybe like a chat stage, and it has been a struggle. And I've been trying to revamp my resume over time, and this is like the latest edition. So I still try to go in for jobs application, but nothing yet. And you had advised I come today and probably share my resume, so you could just maybe have a feel.
Yeah. So let me pull this up real quick. So I mean, your resume looks like nice. I like the layout. This is a very clean and appealing layout. So just kind of looking this over real quick. So you coming from project engineering, project coordinator, data analyst, intern. Okay, so is this considered a career transition? No, because you're pretty new out of school, looks like.
Well, not really sure. I think I've been working for like 7 years as a civil engineer, but majorly into project management.
Yeah. So I mean, like visually, aesthetically, resume looks good. Content wise, we can drill down a little bit more, right? So I'm a huge fan of the STAR framework for talking about how to put stuff on your resume. That's situation, task, action, result, right? So I like that you have all these projects. These are good, but maybe you want to emphasize more about what it was that you did with the project, right? So two things I would say is, first, the project, let's make the name a little bit more interesting and exciting. Make somebody want to read more. So this could be exactly what you did, but maybe you want to make a catchy title for it, right? And when we talk about the STAR framework with respect to the projects, you want to essentially frame it like this, like situation for this project, right? So let me take a step back. Anytime you use a STAR framework, this is how you want to think through it. right? The situation for this project was ... My task was to do ... The actions I took or the analysis I performed was ... And as a result, blank, right? So for your Disney movie analysis project, maybe something can be, for this project, I was interested in discovering what the movie gross income was from a particular set of years to determine which movies drive revenue the furthest. I don't know, I'm just making that up. My task was to do these things, right? The analysis I performed was using the Pareto principle to determine that, blah, 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 right? So on and so forth. Was that helpful? I don't know. I'm talking real quick. I just want to make sure that.
Yeah, it does. It does.
So you want to use that same kind of framework for everything on your resume, right? So here and here, I mean, these are great bits of experience, probably not relevant to data science. So I say keep it as a one sentence like you have it, and I think that's good. But for this one, where it's more relevant to data science, maybe try to use that STAR framework, right? You can say, as a data analyst intern at Uniso, I had the opportunity to work on several projects, some of which included, right? So you have like a opening sentence that's free of the bullet point that just frames what you're about to tell us, and then have 2 to 3 projects that you worked on that were your biggest, highest impact projects, right? So you can say, as a data analyst intern, I had the opportunity to work on several projects, some of which included refactoring existing SQL queries, which resulted in ... right? So you need to put, like, you're putting refactored existing SQL queries, which made queries faster and efficient. Great. How much faster? How much more efficient? Right? Can we translate that into dollars at all? Like, can we translate that into a quantitative value? How do you translate that into a quantitative value? Well, you can say, all right, well, before I optimized these SQL queries, it took X amount of time to run each query. At the standard rate that we have with our cloud service providers, it costs this much money per unit of time to run these SQL queries. So our baseline was X amount of dollars, right? After refactoring the SQL queries, they now run in X minus Y amount of time, right? Which results in Z dollars of reduction from the previous amount, which was a X% reduction in cost, right? Hopefully that's making sense. It's just try to quantify the results of what you did, right? So there's that. Your summary here: determined and passionate data analyst with proven skills in SQL and Python for data analysis, eager to join your team using data to help drive a successful outcome. Like, there's a bunch of words, but I don't like, it's just not really telling me too much about you and what separates you. Everybody who's applying for a job at my company is determined and passionate, and they're all eager. So, like, how are you unique, right? So you want to refactor that summary, right? So you have to think of it this way: whoever is looking at your resume probably has 100, 200 resumes that they're looking at. If they have 100 or 200 resumes that they're looking at, they're not going to spend a minute, 2 minutes on every single resume. They're going to spend 10 seconds, maybe at the most, before they keep going. And if your opening sentence on your resume is that you're a determined and eager data analyst, I'm like, okay, great. So is everyone else. I got to keep moving, right? So your resume, you have to treat it as a sales document, right? So make sure that whatever opening quote unquote paragraph you have for your summary is unique, right? So for example, mine, back when I used to have that on my resume, I don't anymore. It would be constantly learning, self-motivated to try new things, and not intimidated by the prospect of applying newly learned tools to big, complex, messy data problems. I love to get myself in there and find the most optimal solution given the constraints possible, right? And that just tells you all about me, right? Nothing about me being eager or determined, whatever, right? Those are all kind of subjective judgments. but hopefully that's helpful. There's a follow-up question here on a resume. Since it's on point here, why don't you go ahead and have that question, Saurabh?
Yeah, I've heard in many podcasts that in a data science CV we should include GitHub link and any links that show the projects that we have done and maybe some code and analysis. But on the other hand, we also know that the recruiter has got very few seconds to see the CV. He's looking at maybe 100 CVs. Is he, practically, is he or she really gonna look at the GitHub link?
The GitHub link is not necessarily the recruiter that's looking at it. Sometimes they might want to have that there just to see that you've done projects, but really the GitHub link is there is once the recruiter has looked at your resume and says, okay, this looks like somebody that's worth giving to the data scientists to look at, use their valuable time to look at. That's there for them to look at so that they can click on it and they can get a sense of, okay, you passed the HR screen. Now let's take a look at your work, how it looks. Is your code clean? Can I imagine myself working with you, right? Does it look like you know what you're doing? All right, cool. Well, then let's bring this guy in. He looks like he kind of has the basics or fundamentals. Let's bring him in, talk to him a little bit further. The GitHub link definitely is mostly there for the data scientists on the team to look at.
So it's a second level. It's basically a second level screening then. It's not.
Yeah.
First look.
Yeah. Recruiters just going to look at the overall resume and make sure that overall like you're hitting the points that they need for the particular posting, or that your background looks like it lines up. And then they'll see, okay, they also have a GitHub link. Great, perfect. Let's bring them on. I'd also, another thing here I would say to Jacob is this technical skill section, like these dots and stuff, like just get rid of the dots, man. Like I can't tell like what you mean by 2 black dots on Python, 2 gray dots and 1 less gray dot. So that's really vague. Just remove the dots. There's a follow-up question on resumes as well. So Jaya, go for it.
Yeah, Harpreet, I have a question. What if you don't know the quantification or the percentage increase or percentage, if you don't have a quantity number over that, how do you turn that around, make it strong, even though you may not know how much you help the company?
You definitely guesstimate, right? So for example, let's say that, let's give a really high level, super high level example, right? So let's say you came into work and you automated some task, right? Now, before you automated this task, it would take one person 10 hours a week to do this task, right? Now you've automated it down and it takes one person 1 hour a week to do this task, right? So you've saved 9 hours a week on this one task for one person, right? But it turns out that there's 100 people in the company that were doing this one task. So really you save 900 hours per week, right? So 900 hours per week times 52 weeks, it's a lot of hours that you have saved, right? Now this number of hours, right, it's equatable to money, right? You know that it has to be at least the minimum wage times that number of hours. So you know you've saved at least this amount of money for the company, right? So that's how you would do that. Does that clarify anything?
Oh, yes, it does. The reason I ask is like in my past, in my previous careers and so forth, I wish they had taught this in school or something where you can kind of track your value in terms of dollars and time saving and all that, which they don't really teach you, I guess. But yeah, because in my past I was an instructional designer or a designer. I trained, I used to develop learning materials and so forth that the sales guys would go out and take that material or PowerPoint or whatever, job guide or whatever, and they would talk about the products and stuff like that. And because we don't know, they make the numbers. If they make the sale, they get a commission and stuff like that, right? Because they use the learning materials and so forth. But I cannot quantify that, or rather, I wasn't, I wish they had, there was some linkage to it. I don't know how to quantify it now because now it's been so many years. And, I mean, definitely my learning materials would have impacted the sales guy who went out and sold the product and got a commission because he made the sale, things like that, So now it's been so long.
Estimate. Yeah, it's been so long, so that's hard. But one thing you could do is maybe you have some memory or recollection that, you know what, before I cleaned up and redid the learning materials, we had a 10%, hit rate on sales. After I went and cleaned up the learning materials and made it easier, we were now closing not 10%, but 30%. Right? What does you can equate that to dollars if you want to translate it further down along to dollars in terms of top line revenue, or you can just say, well, I helped increase sales by this percentage from creating these learning materials. But yeah, a lot of it is just kind of guesstimation, and it was a long time ago for you probably, so it's okay if the numbers aren't exact, but kind of think about how you impacted it, right? Try to quantify it. And if anybody asks like, oh, well, how did you do that? Then just explain to them how you came up with that number. And I'm sure that will be impressive enough to them that they won't even care about the end result. All right. So next question I got up, we'll make this the last question for today. It's from Suman. So Suman, go for it.
Yeah, my question is, can you suggest so outside of the data science, like there are other the tools that it seems like we need to be familiar or learn, like Databricks or something something like that. Especially the ETL, like what kind of? Because I had an interview last week and they asked me about ETL, like do I have experience in ETL? I don't have it, except the basic ETL that we do within the exploratory data analysis in Jupyter Notebook, and maybe some deployment. So I am like the two ends of the data science. Like, can you suggest like what we can do about that?
So for ETL, like here's an example. Like, do you have any wearable devices? Do you have like the Ring or like an Apple Watch, or do you have any telemetry stuff? Okay.
No, I don't have any.
All right. So let's pretend that you did. Let's pretend that you had some telemetry data from maybe your Ring, right? You got the Oura Ring and your Oura Ring collects data, right? You can build a simple ETL process that would say, okay, every night at midnight, I'm going to have an airflow scheduler in place that is going to go to the Aura API, pull my previous day's activity data, right? And then it'll go through a series of steps where maybe I summarize, aggregate, organize my activity data. And then I have that stored on a local database on my machine, right? That's an ETL process right there. You're extracting data from somewhere, you're transforming it by doing summarizing and aggregating and organizing, and then you're loading it into you can make a data warehouse or you can make a database on your local machine, entirely up to you. So that's an ETL process right there that you can practice, right? If you don't have wearable devices, maybe you have a Spotify account, right? Well, Spotify has a very, very robust API, right? And you can actually access Spotify's API through the Python package SpottyPy, right? And maybe SPOTIPY, SpottyPy. And maybe what you do is you go and you get all of your previous day's listening data, right? And you take all of that previous day's listening data and you aggregate it on certain metrics, right? You can say that on May 2nd, 2021, the average tempo of the songs I listened to was this tempo. The average beats per minute was this. The average acousticness, vocalness, like they have all these metrics on every song on Spotify through their API. You could do that and stash that in a database, right? And then you can go to the Weather Channel API and You can pull that day's weather from the Weather Channel API, right? And then maybe you bring that in, and maybe further down the line, after a month, 2 months of pulling data, aggregating data, you then do a project that seeks to understand the impact of weather on your music listening tastes, right? Like, I'm just making shit up right now. So that's something that, I don't know, that you can probably do, right? And that's ETL right there. Now the deployment aspect of it, you want to make it easy as possible, especially if you're not trying to be a machine learning engineer. So a couple of things you can look at is Streamlit. Streamlit makes it really easy to essentially have like a web service where you can, look at graphs and shit like that. Heroku, you can deploy a web app on Heroku. That's one aspect of it. Or it could simply be this, right? It could simply be that my model deployment is just taking in a bunch of data, right? Doing some type of manipulation, feature engineering on it, doing a prediction, and then stashing the prediction onto a local database, right? That's a deployment. It's a simple deployment, but it counts as a deployment, right? I didn't mention tools or anything because tools are going to depend on the company that you go for. That's more, I think, the principles that matter. Let me know if you have any follow-up questions. I'll pause right now.
I've been hearing about these tools like Databricks, Alteryx, or something.
Yeah, I'm not familiar with Alteryx. Yeah, but sorry. Yeah, go on.
Like how important is it right now in nowadays time to be experienced or fluent to one of those tools?
Yeah, well, all Databricks really is, it's just a way to share work and collaborate. So it's just essentially a notebook in the cloud, right? It's just like Google's Collaboratory. It just makes it easier to collaborate. That's all really Databricks is. So it's not really hard to learn in that sense. You can get started for free on Databricks Community Edition and just play around with it. But I think more important is just understanding when it's useful. Yeah, it's just a managed service, essentially. Managed service for your notebook so that you can collaborate more easily. Because Databricks is cool because two people can work remotely, be in the same exact notebook at the same exact time, working on code together, right? You can comment people's code. You can add. It's nice. It works quite well, but it's not really that difficult.
Yeah, I shall start on ETL. Spotify or YouTube probably then.
Yeah. I mean, you could probably stitch something together on YouTube pretty easily if you just give it a shot. I mean, just start simple as possible, right? So build out the manual process first, right? And then have it so that it works manually. And then from that point, think about, okay, great. Now let me think about how to automate this, right? Then you can get into like Airflow or cron jobs or whatever the hell you want to do. It doesn't matter. But that's how I would start. Cool. Any other questions before we end it off for today? Well, look, man, this is probably my favorite office hour. I mean, from Comet ML, because we had a variety of people. I mean, not to say that I don't love my friends, Tor and Jaya and Christoph, but it's usually just us hanging out chatting. So this was nice to have a whole bunch of newcomers. I just noticed that Auntie is here. Auntie, what's up, man? Thanks for all the support on LinkedIn. Appreciate that. But yeah, it's really good to have all you guys here. I hope you guys do come back and return and hang out. Appreciate you guys coming to stop by. If you do get a chance, tune into my podcast. I released an episode just on Friday with Eleanor Twaddell. She wrote a book that was called Why Losing Your Job Could Be the Best Thing That Ever Happened to You. A mouthful of a title, but it's super relevant even if you're a career transitioner or if you're, if you find yourself unemployed. It's a great conversation we had talking about a book and subtle mindset shifts to get you out of that rut if you are in a rut. So check that out. I got a couple of good messages about some positive feedback for that. So next week we got office hours again, happy hour on Friday. So make sure you check that out. That is Friday at 4:30 p.m. Central Standard Time. And then back next week on May 9th at 11 a.m. Central Standard Time. Looks like I stalled enough, so there are no other questions. Then I can officially sign off now, guys. Thank you so much for hanging out with me. Appreciate having all you guys here. Remember, you've got one life on this planet. Why not try to do something big? Cheers, everyone.
Thanks. Bye, everyone.